As we're calculating probabilities, sometimes we're interested in what are called compound probabilities, where we're looking at multiple events and we're interested in if those multiple events occur together or if they influence each other. And these three formulas overlap with each other a little bit. So please make sure you watch all three of the next videos in this series to make sure you really understand how the three formulas work together and inform each other as we're working with these probability formulas. The first one we're going to look at is the OR probabilities. When I am talking about an OR probability, we are talking about we want either the first event, I'll call it A, or the second event, I'll call it B, or both to occur. And we write this as the probability of A or B occurring. And the way we calculate this is we look at their individual probabilities, the probability that the first one occurred, and add to it the probability the second one occurred. The problem with this formula as it's written is if they both occur at the same time, we have counted it in the probability of A and in the probability of B, which means to undo that double counting, we have to subtract the probability of what we'll call A and B. And just as kind of a side note, because we haven't talked about and yet, I mentioned the formulas overlap. When we say and, that means we're talking about when they both occur at the same time. So to illustrate kind of what this means, to make it make a little more sense, let's do an example where we roll a standard 6-sided die, and we want the probability that we get higher than a 4 or we get an even number. So there's two different events that we're looking at here. We're looking at higher than a 4, and we're looking at even numbers. We want one of them or both of them to occur. And that's using this probability formula. So if I think about the numbers on a die, 1, 2, 3, 4, 5, and 6. If I want higher than a 4, there are two numbers that are higher than a 4. So the probability of higher than a 4, the probability of the first thing, is 2 out of 6 options. Then the formula says we add the second probability, the probability that we get an even number. Well, if I think about the 6 dice, the numbers 2, 4, and 6 are even. There are 3 out of 6 numbers that are even. The problem with this method is it double counts the ones that are both higher than 4 and the ones that are even, both of them at the same time. So we're going to subtract off where they both occurred at the same time. And if you notice in my little diagram, the number 6 was in both groups. There is one number out of 6 that occurred in both groups. So we have to subtract that one off. So we add the individual probabilities and then subtract off where they both occurred at the same time to get my total probability. 2/6 plus 3/6 minus 1/6 is 0.6667 as a probability decimal. So the probability I get higher than a 4 or an even is 0.6667.